During the recent years, we have all enjoyed a flurry of stunning pictures of distant stars and galaxies. For scientists, such images provide new insights into the nature of celestial objects and thereby into the physics that determine their appearance and evolution. The sharper the images are, the better. This is why telescopes like the ESO Very Large Telescope and the Hubble Space Telescope are so important for the scientists. Already long ago, however, astronomers realized that by using a special method called optical interferometry, they might be able to study their objects with much higher precision still. The only problem was that optical interferometry is exceedingly difficult to master. The Paranal Observatory in Chile, home of Europe's Very Large Telescope, the most advanced ground-based observing facility in the world. Interferometry requires the light from two or more telescopes to be combined. When the Very Large Telescope was conceived as an array of 8.2-meter telescopes, it was designed to work as an interferometer. But it meant doing interferometry on a scale never attempted before with any astronomical telescope. In March 2001, ESO carried out the first interferometric test observations with great success. Since then, the experts have worked on refining the technique, while at the same time adding new specialized telescopes to the array.
Yes, wonderful approach.
The new telescopes are 1.8-meter telescopes that, unlike their larger brothers, can be moved around on a system of rail tracks. This way, the distance between them can be varied according to the needs for individual observations. By observing the same object with different telescope configurations, it is possible to obtain images that are 100 times sharper than what can be observed with the Hubble Space Telescope. Until recently, only one of these special so-called auxiliary telescopes had been delivered to the Paranal Observatory. Now, however, ESO has commissioned its second one.
Combining the light from the first two auxiliary telescopes mark an important milestone for the development of the VLTI interferometer. Because we can move this telescope around, we can now observe with many different distances and orientations between the telescopes. This is a key feature for high angular resolution imaging. You have to imagine each telescope being 30 tons of very high precision mechanics, optics and electronics, able to move around during the day and deliver the same evening very high quality images.
Now, interferometric observations can be carried out continuously without interrupting observations with the main telescopes. But the real importance of these additional telescopes lies elsewhere.
The introduction of the auxiliary telescopes is a very important new milestone in the development of the VLT interferometer, and will bring interferometry out of the specialist experiment and into the domain of common user instrumentation for every astronomer in Europe, and will increase enormously the potentiality of this observatory.
With two more telescopes still to be delivered this year to the Paranal Observatory, ESO cements its position as world leader in ground-based optical astronomy, providing Europe's scientists with the tools they need to stay at the forefront in this exciting science. The VLT interferometer will, for example, allow astronomers to study details on the surface of stars, or to probe protoplanetary disks and other objects for which ultra-high precision imaging is required. It is premature to speculate on what the Very Large Telescope Interferometer will discover, but it is not difficult to imagine that there may be quite some surprises in store for all of us.